Today I'm going to talk about the outreach for Hayabusa2 and MMX, and one of the main reasons I'm going first is I'm going to try and give a broad flavour of the different types of outreach done for each mission. And then Yoshikawa-san will follow me with a more in-depth look at perhaps one of the hardest areas of the mission outreach, that of the live events. So, although I am going to focus on the outreach, I thought maybe there might be some people in the audience who are from different areas outside space science, and they might not be very familiar with the Hayabusa2 mission itself. So I'm just going to do a few quick slides talking about the mission, so what we were actually discussing during the outreach. So the three-picture summary of the Hayabusa2 mission is that it ran from December 2014, which is launch, through to December 2020, when the spacecraft swung back by the Earth to drop off a capsule full of samples from its destination, Asteroid Ryugu. And during its stay in the vicinity of Asteroid Ryugu, which stretched from approximately the end of June 2018 through to the 13th of November 2019, the spacecraft took a lot of scientific observations of the asteroid and also collected 2 samples from the asteroid's surface. And then on the 6th of December 2020, the spacecraft came close to the Earth. It separated a capsule containing those samples, which landed in the Australian outback in Woomera on December 6th. The spacecraft itself did not re-enter the Earth's atmosphere, but swung past the planet and is now off on an extended mission. So just for the science, like, why do we want to go to asteroids? So asteroids normally sit in the asteroid belt, which is between Mars and Jupiter. And this is actually quite a long way away from the Earth. However, collisions between asteroids or interactions with the gravity from Jupiter and Saturn can cause asteroids or fragments of asteroids to come nearer the Earth and orbit between the Mars and Earth itself. And we refer to these as near-Earth objects or near-Earth asteroids. And Ryugu, the destination of Hayabusa2, is one such example. Now, these asteroids can be a danger to Earth. They can collide and cause really terrible devastation. However, asteroid Ryugu is not on a course that is considered dangerous to our planet. But its interest is rather not in how we might end, but in how life actually began on the Earth. So asteroids themselves are really rocky planetary leftovers. They're kind of the nuts and bolts that you inevitably end up with when you build yourself an IKEA flat pack furniture or one from Nitori. And this means that they are evidence of how the planets themselves formed. Now, there's different types of asteroid, but a particular interest for us, because Hayabusa2 visited it, is a C-type or carbonaceous asteroid. And these have a particular properties that makes them quite exciting. Firstly, they are what we call a primitive asteroid, which means that they haven't really undergone a whole lot of changes since the start of the solar system, roughly 4.56 billion years ago. And this means that they are very similar to the asteroids that would have hit the early Earth. Now, we actually think that the Earth did not form initially as a planet that was particularly habitable. In fact, it may have formed really dry without liquid water. And it's possible that this water was delivered by asteroids like Ryugu, scattered inwards from further out in the solar system where they could have ice as part of their structure, and hit the Earth's surface, delivering water and maybe even primitive organics that might have been the start of life. Yes. So during the mission to Asteroid Ryugu, there were a whole series of very key operations that were important, obviously, for the mission itself, but also very important from the point of view of the outreach. So obviously, launch was kind of a big deal. That was early December in 2014. 1 year later, the spacecraft swung by the Earth and received a gravitational push from our planet's gravity, and that changed its orbit into one that was very close to asteroid Ryugu. It arrived at the asteroid's vicinity at the end of June in 2018, and then started a series of surface operations, which were perhaps the most thrilling part of the mission. One of these was the separation of 2 little rovers called the Minerva 2-1 rovers that were actually demonstrating autonomous motion on the asteroid surface. So they were detached from the spacecraft, they landed on the asteroid surface, and then they actually sprung or hopped across the asteroid surface. And their principal aim was to demonstrate how you could move successfully in a very low gravity environment where wheels or caterpillar tracks just wouldn't be effective because there's not enough friction. Shortly after that, the mascot lander was detached from the spacecraft. This is a shoebox-sized laboratory that was developed by the German and French space agencies. And it also landed on the surface of the asteroid and was able to do very close-up science because it was actually physically on the surface. And this was great for comparing with Hayabusa2's more remote observations. Then in early 2019, we did the first touchdown. So this spacecraft itself actually descended to the surface of the asteroid and scooped up a sample of material. This was followed later in the year by an impact experiment called the Small Carry-On Impactor. So in this experiment, Hayabusa2 dropped a small detonation device that blasted a hole in the asteroid to create an artificial crater. And this was scientifically pretty fascinating for a number of reasons. For a start, you got to see the sort of tensile strength of the asteroid's surface, and that gives clues to its age. And secondly, what it did was eject a lot of material that is just below the surface. And the advantage of this is while Asteroid Ryugu probably hasn't undergone major changes since formation, the surface nevertheless would have been affected by things like cosmic rays, radiation from the sun, and micro impacts from incoming tiny meteorites. But the subsurface material should be even more pristine. And that brought us to the second touchdown, where we touched the spacecraft down close to the artificial crater, where it was thought that material from that crater had been ejected. There was then actually a gravity experiment done with a final little rover. And then finally, the spacecraft departed from the asteroid itself and returned back to Earth in December 6th last year, so just last month. So I couldn't resist showing some images of just the highlights of the mission. This is a short movie showing the asteroid's approach at the end of June 2018. And you can see the asteroid is now coming into sight. Prior to seeing it, we didn't really know what the structure would really be like. We just had a light curve to go on. So this was really an amazing moment. And as you can see, this is quite clearly a Death Star. It has a very notable crater just above the equator. And it really does look like the Star Wars Death Star. But in fact, fortunately, turned out it was not. So this is an image of the asteroid close up. And this is an image of the asteroid really close up at an altitude of just 64 meters. And this was taken as a spacecraft descended low over the asteroid's surface to drop off the mascot lander. And the two little rovers I mentioned actually were fitted with cameras themselves. And so this is rover cam. This is what it would look like if you were hopping along as a very tiny rover on the asteroid's surface. And then this movie is one of two that were taken during the first and second touchdown. And this is pretty interesting because it's taken with Cam H, the small monitor camera that looks down the sampler horn of the spacecraft. And this was actually fitted to the spacecraft through public funds. And it's taken possibly some of the most stunning images of the mission as you look down actually at that touchdown process and the gathering of material. So why is outreach important? And I sat down and thought about this question for a while, like in a nutshell, why would I say that, in addition to the science and technological objectives of the mission, why do we care so much about outreach? And what I really wanted to say is that, as we have to make career decisions in our lives, but just because you didn't pick science when you were 16 or 18 doesn't mean you are no longer interested in it. And perhaps you made slightly better life choices that involved perhaps better salaries or less stress about things that happen 300 million kilometers away. But I think, you're still allowed to be interested in science and you should still be able to study it even once you leave school. So a little more formally, I would say the reasons that certainly I'm interested in outreach are that, space missions provide an opportunity to learn about science and engineering that are pretty rare once you leave school. I mean, once you stop formal education and you've decided to do something, to pick a career, maybe become a doctor, a vet, or an artist, where are the opportunities to expand your knowledge about science and engineering? They sort of vanish. So I think space missions are an amazing opportunity to continue with science and engineering education, because rather than me saying, oh, why don't you go back to your high school textbooks and look up, tensile strength of rock, it's much more exciting to say, why don't you come on the journey with us to a world no one has ever seen before? And to understand the images you're going to see, we're going to tell you a little bit about the science, and it's a much more accessible way of learning about really very advanced science and engineering. Linked with that, of course, there are people who still are in school, and they may be considering about their careers in the future. And it's sometimes hard to inspire children in STEM. It can seem very dry, but a space mission is really anything but dry. You're seeing a whole new world. You're seeing, science and physics that simply can't be done in the classroom. And so it's an inspiration, I hope, for younger people and to encourage the next generation of scientists. Also, even among the scientific community, I think outreach has a really important role. When you do an outreach article, unlike when you write a journal paper, you try and avoid jargon because it just obscures the meaning. And that's actually really valuable across scientific fields as well. So for example, as I mentioned, Hayabusa2 is sort of concerned with how life might begin on Earth and how habitable planets form. Well, that's also an area that's immensely interesting to astrophysicists looking at exoplanets, but they might be publishing in very different journals to the ones that planetary scientists are publishing in. And so they might miss key results. We're about to collect really one of the only samples that you can collect that's relevant to origins of life. And it's very relevant for understanding not just how the Earth became habitable, but how planets around other stars might have become habitable too. So sharing this information across fields when we might be reading different journal papers using different language is really important. And I think outreach is really the principal way of doing that. Also, it supports our partners. Hayabusa2 is led by JAXA, but it's a very international mission. We have major contributions from Germany and France for the mascot lander. We collaborate very heavily with the United States OSIRIS-REx mission. And the team decisions are informed through a joint international science team that consists of scientists all over the world. So by doing outreach, we promote not just only our own activities, but also those of our partners and help them, we hope, to be successful. And it's also a very good reason for making the outreach bilingual, so that it's not just disseminated within Japan. The other reason for doing that is that Hayabusa2, it's searching for the origins of life on Earth. It's a story of everyone, not just of scientists, not just of people in Japan, but really the world over. And so the results should be shared as widely as possible. And so with this in mind, the Hayabusa2 outreach program really from a very early stage was designed to be bilingual, with both as much news as possible put in both Japanese and English as simultaneously as possible as well, so that you don't have, a week's delay for the English to come out. We tried to do it really, at the same time as the Japanese, so it's hot off the press in your preferred language. Now, I don't want to take credit for the Hayabusa2 outreach program because I was not the mastermind behind it. The outreach program is led by the mission manager, Yoshikawa-san, and we'll be hearing from him next. And I feel that actually a quote I found from him on a paper I was reading really sums up everything I've put on the left-hand side here, where he said that missions must be such things that make people happy. Like if we haven't achieved that, have we really achieved the main goal of the mission? And I would say, no, we've missed it. So I think this is really important. So the Hayabusa2 outreach program, I joined at a relatively late stage. In a sense, I really joined when we were doing the Earth swing by 1 year after launch. So the program already had a spacecraft, which helps definitely with outreach. And we were approaching a very busy stage of the mission where we were going to have a lot of results coming out on sort of a weekly basis. And these results were broadly organized into 5 areas, in my personal opinion. There was the regular news. So this was typically website and Twitter articles. And the main key here is there are frequent updates on all aspects of the mission. So there's no big gaps where you don't have any news. The articles were released very frequently. So there wasn't like a big pause where you heard nothing. That was one of the key points. Accompanying this were real-time events. So this is like simultaneous news releases during big operations. And the idea here is to make you feel as much as possible you have a front row seat, like you are, okay, virtually, but as close as possible, sitting in the control room with the scientists, watching as things evolve. The third part is actually opportunities to get involved. So during the mission, Hayabusa2 ran 9 different campaigns to encourage really anyone to contribute to the mission through a variety of different ways, which I'll talk about a couple of them a bit later on. And finally, there were the talks where you actually got to meet the team. So many members of the Hayabusa2 team gave live talks, both close to campus in Sagamihara, and also touring through Japan as much as was possible during 2020. So if we look at the first one, which is the regular news updates, these were primarily posted on our mission website, hayabusa2.jaxa.jp, which has both an English and Japanese version. And the types of articles that were posted covered quite a broad range. For example, there were image releases from the mission. This shows actually the most recent one, the claiming of the sample capsule in Australia. So every time I look at it, I sort of become speechless again, because it's just amazing to think that this was actually a sample capsule that was released from a spacecraft with material collected from Asteroid Ryugu, and there it is on the Earth in the Australian outback, roughly where we thought it would be. It's incredible. Also, there are operation descriptions. These are more long form articles describing why we might be doing a particular operation, how we might be doing it, and explaining as much as possible, the decision-making process that goes into the different events during the Hayabusa2 mission. Then there is journal paper reviews. So journal papers are largely incomprehensible unless you are in the field yourself. So the website also publishes more digestible versions where you just strip away the jargon and you explain exactly what the paper was looking for and what it found and why it's important. There's also team updates. So this particular one was the arrival of the Micro Omega, which was an instrument that's going to be used to analyze a sample, and it came in from France, and the team had collected it. And also sometimes we do messages from the teams, especially thanking people for support and things we're excited by. And then there's also fun news. So this particular article was some members of the team met Brian May of Queen. Brian May is actually an astrophysicist, and he's very keen on stereoscopic images. So he actually asked the team whether they could send him some images to make a 3D picture of Ryugu, and you can see that on our website. It's really cool. So you can actually, if you have just the red and green glasses, or if you can cross your eyes in a certain way, then you can see Ryugu in 3D thanks to Dr. May, which is amazing. And the articles on the website were mainly shared through the Twitter feed. So most people just follow the Twitter feed, and then when we had an update, we posted both in English and Japanese. The top one is the English feed, Haya2 JAXA, and then Haya2_JAXA is the Japanese feed. And the target audience was everyone. Really anyone should be able to look at these and understand them, from scientists through to the press. They often use images directly from our Twitter feed. So quite often I'd see an article on the BBC News where it is just a screen grab of the Twitter feed, which is quite fun. And also to help with the operation flow, a lot of infographics were done for the mission. So, you have, in this particular example, the spacecraft was dropping low over Asteroid Ryugu and then rising back up. And you see that sort of graphically in the top diagram, and then a more pictorial bit for the really close-up operation. And this is just a better way of visualizing what's going to happen. And typically these infographics were released a day or two before the operation itself, so people could take a look at them and be ready for the real-time events. So the way to release information in real time, there's different ways we did it, but one of the principal ways was actually via the Twitter feed. So during really almost all our operations, we would do real live updates on Twitter. And you can see here this particular operation, I think actually is for the first touchdown. And we post, the schedule, but also as we go through, for instance, the gate checks to say, yes, we've checked the spacecraft, it's still looking good, we're going to continue with the operation, or we've checked our ground control, the weather's clear, we've got good communication with the spacecraft. All those sort of updates that people are doing in real time in the operation room were tweeted live, so you could follow along. And at the same time, for the low altitude operations where you saw the asteroid coming closer and closer and closer, we actually automatically uploaded images from the camera on board Hayabusa2 to a website gallery. So you could also watch in real time the asteroid approaching and then ultimately receding again. The actually biggest events in real time, I'm not going to say too much about, because this is what Yoshikawa-san and Hosoda-san are going to talk about. And these were for the really big events like the touchdowns, and I think we did one for the impactor experiment. We did live web events where people actually discussed the whole thing live on camera on YouTube. But I will leave that for the next talk. So the campaigns were opportunities to get involved with the mission. And one example of what was done was the first one, which was actually done just before launch, called Let's Meet Le Petit Prince. And this is obviously based on the novella about a small boy who lives on an asteroid. And it was a name and message campaign. So people were invited to submit their names. And these names were sewn into target markers, which were left on the asteroid. So target markers are these small balls here you see in this CG animation, and they land on the asteroid's surface, and they're very reflective. And the spacecraft can use these as a guide to land safely, because it has basically a lighthouse that can measure it. It can measure its position and velocity relative to. So the names were sewn into the target markers, and these were left on the asteroid itself, and messages went actually on the entire mission, because they were put into the re-entry capsule. So they went to Asteroid Ryugu, and then they came back to Earth again. So it was a way of virtually traveling on the space mission. In total for this campaign, we received just over 400,000 submissions. Now, the majority of those were within Japan, but there were still, over 100,000 that came from overseas. And this was before the mission launched. So I think it's really exciting that we got so much response from overseas. And this was helped by advertising through the American Planetary Society, who helped advertise our campaign in English as well. And so that allowed it to have a broader reach than perhaps it would have done if we'd only released it on the JAXA website. And this is a picture of what the names look like when they're sewn into the target markers. They're engraved on a very thin sheet of aluminium, and this is wrapped around each target marker. And each target marker, I think, has the same names on it. So. Later opportunity was Imagining Ryugu, and this was also one that was really accessible to everyone. So before Ryugu came to sight, we didn't know what it was going to look like. So people were asked to submit their artwork of what they think the asteroid what might look like. And we didn't want to limit people's imagination here to just drawing, round space rocks. So there were 3 categories. There was a lookalike award for a real asteroid. There was the most fun submission and the most imaginative entry. And there was also 6 different age categories for each prize. And over 2,000 pieces of art were submitted. So to get people involved, what JAXA did is they advertised for what we call nodes. So these were science museums or planetariums that would locally collect artwork from their local population. And then they would judge all of these internally, and then they would send their best entries onto JAXA for like a grand prize at the end. And most of these were overseas, most of these were in Japan, but we still had over 100 entries from overseas as well. And as we got close to judging the competition, we asked also members of the team themselves to submit what they thought Asteroid Ryugu would look like. And this actually formed one of the most hilarious blog posts I think I translated. So this is what our project manager, Suda-san, thought Asteroid Ryugu might look like. And I have to say, this is wildly optimistic. You'll note that most of the asteroid is this beautiful flat plane, very easy to land on. There'd be no problems finding a touchdown point on this particular artificial asteroid. Unfortunately, we were not quite so lucky as that, but it's a very fun idea. And the second one came actually from head of sample analysis, Tachibana-san, who said he was really hoping to find organic matter on Ryugu. So really it'd be best if the whole thing was just a potato right there. And then there'd be plenty of organic matter to take a look at, and honestly, quite some questions as well. So there was also campaigns that were more difficult to do. So in particular, there was a couple of campaigns to observe Ryugu or Hayabusa2 during their close approaches to the Earth. So the last of these campaigns, both Ryugu was reasonably close to the Earth, and Hayabusa2, of course, was coming back to drop off the sample capsule. And so there was an observation campaign for people to observe it from Earth. And I mean, this is more difficult. You do need pretty skilled amateur astronomers to make these observations, but nevertheless, it was great. For both the campaigns, we had quite a lot of entries, and this is an image taken from Kyoto University's Okayama Observatory, and you see on the right, that's actually the separated sample capsule, and on the left is the Hayabusa2 spacecraft. And 140 locations joined in this campaign, mainly in Japan, but a few overseas. And these 140 successfully observed Hayabusa2, and 10 got both the spacecraft and the re-entry capsule. And the team were helped by this by support from both the Japan Public Observatory Society, which mainly helped, I think, observatories, and then also the Planetary Society of Japan, which worked, I think, more with individuals to both advertise the campaign and offer support. Did I not have a final slide? I thought I had another slide on Meet the Team, never mind. So English translation for this was really my role in the mission. So I joined shortly after the swing by of the mission. And I largely worked from the Japanese material. I wrote a few original pieces of my own, but largely the material was in Japanese and I translated into English. And my takeaway message was that translation is more than just words. So for example, here's one example of the Japanese drama dolls, where the team had a whole series of these that were stacked up in the control room. And for big mission operations, they obviously drew in one eye to represent a goal. And then when that was succeeded, the second eye was drawn in. And these are very popular in Japan. So no Japanese person would need an explanation of what these were. But when you translate into English, it wasn't enough to say, oh, they're drawing in the second eye. People would be like, what eyes, what? There's a little bit of explanation was needed in the English that just wasn't there in the Japanese to explain why you do this. Likewise, when the Hayabusa2 team flew to Australia to collect the capsule, the flight number was 8823, which in English means absolutely nothing whatsoever. But in Japanese, you can actually pronounce that Hayabusa. So that was very exciting. But again, extra information was required for the English side. Another example as well is the control room has a mascot, which is a oarfish. And if you speak Japanese, you know that's pronounced Ryugu no Sukai. So that would be very obvious why, obviously, it was the mascot for a mission going to Asteroid Ryugu. But in English, it's an oarfish. So, I mean, why do we have a fish in the control room? So, again, a little more explanation was required every time the oarfish appeared in one of the tweets. And this is perhaps my most hilarious moment. So I speak basic Japanese, but it's not very good. So I largely use Google Translate to give me a rough idea of what an article is saying. And then my knowledge of basic Japanese, coupled with a good knowledge of what the mission is about, allows me to do what I hope is a close to perfect translation. But sometimes also translators go very strange. And there was one where I just put in the Japanese and I typed it into Google, and Google said, oh, you're collecting Lego squirrels from Asteroid Ryugu. And I was like, I'm thinking maybe we're not. I would be quite surprised if the team expected Lego squirrels on Asteroid Ryugu. And it turned out that it was in katakana. It's regolith. So the top layer of sand on a surface is the regolith. It's written in katakana because it was an English word. But Google have thought, oh, Lego, ris, squirrel, Lego squirrels, ta-da. So I think, you have to keep your wits about you when you're translating. Otherwise, the results can be very, very strange indeed. So for comparison to the Hayabusa2 mission, I'm also on the outreach team for JAXA's next mission, which is the Martian Moons Exploration Mission, or MMX. And this mission is due to launch in the financial year of 2024. It will observe both the Martian moons Phobos and Deimos and return a sample from Phobos in 2029 to Earth. And it has two main science questions. The first of these is, how did the moons of Mars form? And there's two major theories. One is they are captured asteroids that were scattered in from the asteroid belt, snagged by Mars's gravity, and became moons. And the second is they formed during a giant impact with Mars, which is actually how our own moon formed. But whichever these turn out to be is rather exciting for understanding the habitability question. If you are on team capture and you believe these are captured asteroids, then what you're seeing is how water moves through the solar system, because these moons would have formed from further out and then been directed in towards the terrestrial planets. So if they contain a lot of ices and organics, that tells you sort of where these were forming and where they were moving. On the other hand, if they are from an impact with early Mars, then they're actually time capsules to what conditions might have been like on the young planet. And it's thought that Mars was much more habitable during its early days. So you'd end up with a sample of what early Mars, potentially habitable Mars, might have been like. The second big science question is, how did the surface of Mars itself evolve? And as we mentioned, Mars maybe went from a habitable planet to an inhabitable one. And oddly enough, these might be ingrained on the moons of Mars itself. So as little micrometeorites or big meteorites hit Mars, material is scattered up from the surface. A very small amount of this makes its way to Earth, but far more will make its way onto the Martian moons. So when we collect a sample from Phobos, we may also be collecting Martian material. And by using radioactive isotopes in that sample, you can actually date it. So you end up with a sort of chronology of the Martian surface back through time. Now, in terms of outreach, I would say the biggest question I had with this mission is, we don't yet have a spacecraft. So how do you do mission outreach? I joined the Hayabusa2 mission after swing by. We were on a brink of getting a lot of results, a lot of images. There was tons to discuss about the mission. But for MMX, we won't actually launch until the financial year 2024. So how do you start boosting interest in a mission at this stage? So as with Hayabusa2, we wanted a news website, and we wanted this very much to be both in English and Japanese. And so we have this. If you go to MMX ISAS JAXA JP, and then you click on news, you'll find a whole list of news articles, which is, even though we don't have a spacecraft, we've got news. So what sort of news can we share? Well, the mission itself is progressing. So we have mission updates. For example, recently we have a rover landing test. MMX will carry a small rover developed by German and French space agencies again. And this was undergoing a landing test to check it could land safely on the surface without anything bad happening to it. So these drop tests, we reported on that. Also, we recently planned an addition to the spacecraft of high-resolution cameras that have been developed jointly by NHK and JAXA. So that announcement and plans for those were put on the websites. And also there's been very relevant science done to the mission, like planetary protection associated with collecting a Phobos sample. Is there any risk there? Do we have to worry about either contaminating Phobos or reverse contaminating Earth? And so discussions like that are added to the website. The answer is no, we don't have to worry about anything. But then we can also add news that is relevant to people who are interested in the MMX mission in general. For example, there is papers being published looking at Mars's evolution, and some of those are by JAXA and some of them are by other research groups. But if we thought about really, the people who are watching our website, what are they interested in? Then they're interested, presumably, in the formation of the moons and in formation of Mars. So we have written sort of digestible summaries of these research papers to sort of show where the thinking is at the moment and how the MMX mission might help solve some of these questions. So one of them recently was, could Mars actually have had rings at one point from a previous generation of moons that would have hit the Martian surface, disintegrated and formed like a band of rubble around the planet to form a ring that may have coalesced into the moons that we see today? Also, another one was, how much organic material might we find on Phobos that originated from Mars itself? And this was a look at actually Martian meteorites and what they can tell us so far about the evolution of Mars. And also just news about Mars in general. For instance, last summer, basically everyone went to Mars. There was a mission from 3 different missions. There was one from the United Emirates Hope Mars mission. There was China's Taiwan 1 Mars mission. And of course, the US Perseverance rover also launched, all in the same period of time. So we wrote an article saying, why now? Why is everyone going now? And the answer is to do with orbital alignments. And we discussed that in that article. So we have 2 accompanying Twitter feeds that are actually very, very active for the mission. And for these, we have articles from our own news site, but we also share news from across JAXA. So not just from MMX itself, but from other sites on JAXA. So here we've shared news about the gateway that JAXA is involved in, and also the message from Noguchi-san, who's currently on board the ISS space station. He did a New Year's message, and we shared that. And also news again from other Mars missions that would be interested to people following the MMX mission, from NASA's Perseverance in this case, but we've also shared posts from the Hope mission and other similar ones. So I would say that doing outreach at this stage in a mission is a little different because we don't have a lot of results coming in, but it gives you some opportunities to experiment that's been very exciting. So for example, I've enjoyed working with other divisions in JAXA. This is a great example. The video by Noguchi-san was originally released only in Japanese, and I suggested to our MMX team that we produce subtitles for it. And Tokuchi-san, who I work most closely with on the MMX Outreach, contacted JAXA headquarters PR and the ISS PR and said, would it be okay if we added subtitles to this? And we did, and then we shared the video with them. And then they shared the video on their feed, and then we shared again their tweets. So we were it's really nice to work more closely with other areas at JAXA. A second one is we've done some videos to explore different ways of communicating. This was a Blackboard video that discusses, how did the moons of Mars form? And we did this both in English and Japanese. And it's just a little diagram talking about the formation of Phobos on Deimos and what we might learn from that. And lastly, and perhaps my most favorite, are cartoons of the spacecraft. So I've been learning Blender, and I wanted to try it as an outreach tool to do little animations that I thought people would enjoy. And so we've used these both to just say like Merry Christmas and like fun little things like that, but also little animations that connect the missions together. So in this animation here, MMX is waiting for the return of Hayabusa2 and the sample coming in from Ryugu. So just to summarize, I would say that, bilingual translation is not particularly hard, but you do have to watch it a little bit. If you join a mission at an earlier stage, you have opportunities to experiment, which are really, really fun. On the other hand, if you join a mission at a later stage, you're absolutely packed with results, and that couldn't really be more exciting. So please do keep an eye on our missions. Hayabusa2 is not over. The spacecraft is continuing to an extended mission. And our Martian Moon exploration mission, our outreach is booming. We're sharing news from all over JAXA, from other Mars missions, and I hope you'll follow us. Thank you very much.